Student is asking for help with this sort of problem where we take a recursive formula and derive a explicit formula. Consider a population that grows according to the recursive rule P sub n equals P sub n minus 1 plus 30, with initial population P sub 0 at P sub 0 equals 20. So they want us to find a few terms of this. And of course, the goal is going to be to find P sub n. Well, here, the n is 1. N equals 1. In other words, at time t equals 1, or the term after the initial term when t equals 0. What is that? Well, n is 1. So we're going to take that 1, we're going to throw it right into there, because n is 1. P sub 1 equals P sub 1 minus 1 plus 30. 1 minus 1 is 0. So P sub 0 plus 30. P sub 0 we know is 20. So this is 20 plus 30, which is 50. So P sub 1 is 50. We could run the same kind of thing for P sub 2. Let's see. P sub 2 is P sub 2 minus 1 plus 30, which is P sub 1 plus 30. P sub 1 we found to be 50. So this is 50 plus 30, that's going to be 80. 80. So basically, this series is just add 30 every time. That's basically what this says, right? The nth term is the previous term plus 30. Okay. Now that's recursive. That tells you how to get the next term given the previous term. But what we want is an explicit formula for the population, which is different. That's not, that's not, okay, here's what happened the previous time. What happens this time? It's different. It's inputs and outputs. So input a value of n, and what's the output? What's the population for n equals whatever? Well, let's see what's going on with these different values of n. And right now we know 3 different values of n and their values of the population. We know 0, we know 1, and we know 2. Okay. So it's good to make a table to figure out what's going on with this sequence of populations. For different values of n, zero, 1, 2, the P sub n's for those we found to be, we were given 20, and we found 50, and we found 80. Okay, that's the process. So how did we get those? Well, the first one was just 20, and that was given. Now that initial amount for the population, I mean, that's always part of it, right? That 20, that's always going to be part of it. We're basically looking at these numbers and hacking a formula just by noticing a pattern. Well, I mean, we know that number 30, so we feel like that's going to be part of this. Well, it is, because you add 0 to 20 to get to 20. In other words, 30 times 0 you add 30 times 1, that is 30 to the 20 to get to 50. You add 30 times 2, that is 60 to the 20 to get the 80. And so we can see what we're doing with these values of n. We're multiplying them by 30 and adding 20 to the result. So, what if it's just n then? Well, it's the same, right? 30 times n plus 20. And that is your explicit formula for this phenomenon, this population growth. And when you come up with what you think is a correct explicit formula, we think we've got that here because, we derived something, but you should always check it and verify, that does work, that that is the answer. Well, let's see. Does it work for all the things that we know that we have figured out from the given information and from doing a little math? Well, yeah, you put 0 into that expression in the circle and you have 20. You put 1 in there, you have 50. Put 2 in there, you have 80. So it works. Okay. This is linear growth, by the way. So there is our explicit formula. P sub n equals 30 times n plus 20. 30 n plus 20. Now we can figure out what it's going to be for any value of n. They're going to say use your explicit formula for some particular value of n that someone might be interested in. N could be a number of weeks, a number of years, or some lesser interval. Okay, so let's see. And that is 100. No problem. We'll just take that 100, we'll throw it right into for n, right through the math and see what the population will be at time at the 100th week after the initial, or whatever the time interval, day, minute, the 100th time period after the initial. So this is going to be $30 times 100 plus 20, which is 3,000 plus 20. So P sub 100 equals 3,020. Hope you found this helpful.